Now here's a question where you're asked to solve this equation right there, and asked to solve it by completing the square. Turns out there's lots of ways to solve that. You could try and factor it. I don't know if you could factor that one. Don't think so. You could use a quadratic formula. You could graph it lots of ways. If they specifically say solve by completing the square, here's how you could go about it. So 2x squared plus 7x minus 15 equals 0. So what I'm heading for at the end is I want to get a perfect square of something is equal to some number. And this being a perfect square, I'll be able to write it like that. And then I want to square root both sides. So that's sort of where I'm heading. But the first thing I need to do is on the left side there, I need to figure out a perfect square for it. So if I have an equation like this, I would move the 15 to the other side right away. So 2x squared plus 7x equals 15. Then having a 2 out front there causes problems with completing the square. Again, if you have an equation, there's an easy way you can get rid of that 2 is just divide everything by 2. So you'd have x squared plus 7 halves x is equal to 15 halves. Okay, now here's where you take the middle term, or what's going to become the middle term, the 7 halves. So take 7 halves, and you divide it by 2, and then you square that. Typically, you can do that on your calculator, and it'll come up with the answer for you. Here's how I have to do it in my head. I have to go 7 halves divided by 2. That's what this line means. Divided by 2 squared. Or 7 halves. Okay, so I have 7 halves. Instead of dividing by 2 over 1, I'm going to multiply by 1 over 2 and then square. Or I can multiply across now, so 7 times 1 is 7, 2 times 2 is 4, and then I have to square that, so I'm going to get 49 over 16. Okay, so I'll have x squared plus 7 halves x is equal to 15 halves, and this thing here is what happens over here. So plus 49/16, that's what's going to make it a perfect square. But if I add it on that side, I have to also add it on this side. Okay, so now this is a perfect square, and you can go right to this spot here. You can go x plus, and then the number you put in here is this number before you square it. So it'll just be s plus 7 quarters squared is equal to, and then you add the stuff on the other side. That'd be 120, 169, I think. 169/16. I don't know if that's right. It's got to be right. Times by 8, times by 8, 4, 120. Yeah, 169 over 16. Okay. Oh, just to confirm this, that this is correct. You could, if you want, go over here and go 7x plus 7 quarters times x plus 7 quarters and FOIL it out. So it'd be x squared plus 7 quarters x plus another 7 quarters x plus 49/16. And then 7 quarters and 7 quarters is 14 quarters, which when you simplify gives you 7 halves. And that's what I have here. So I was just confirming that factoring that is correct. Okay, and now I can use the square root principle. So I can square root this side, and that'll cancel the square. And if I square root this side, I have to square root this side. And on the right side, when you use the square root principle, you always have a plus or minus. So now I'll have x plus 7 quarters by itself, no more square, is equal to the plus or minus square root of 169, I think is 13. And the square root of 16, I think is 4. So, if I just finish this then, I'm going to split it into 2. So I'm going to have x plus 7 quarters is equal to a positive 13 quarters. And I'll have x plus 7 quarters is equal to a negative 13 over 4. Subtracting 7 quarters on each side on this first one, I'll get x is equal to 13 minus 7 is 6 quarters, which you can simplify to 3 halves. So that's one of my answers. And then the other answer, I'll have to subtract 7 quarters again on each side. So I'll get x is equal to, that'd be minus 20 over 4. Oh, and you can divide that with minus 5. So those would be my two answers. Now, if I'm getting answers perfect like that, I could probably factor. Let's try it. So if I take the original equation, 2x squared plus 7x, and I'll bring the 15 over to this side and call it minus 15 equals 0. I guess that's how it started. I might have been able to factor that. So I'm thinking I put a 5 over here, maybe a plus 5, and a minus 3 there. Let's just confirm. 2x squared plus 10 minus 3 is 7, yeah. And minus 3 times is minus 15. So if you solve each of these, 2x minus 3 equals 0, and x plus 5 is 0, you get x equals minus 5, and on this side you get 2x equals 3, and x is equal to 3 halves. Yeah. So I guess there I just showed quickly that you can solve that two ways. This is the complete the square way. As you can tell, that's a whole lot more difficult than just plain factoring. And I could have used the quadratic formula too. Alright, hopefully that helps you out.